All right, let's get
Awesome.
into it. You guys can see this, right?
Yeah.
Yep.
I'll give my take and then we can discuss some of the details. So what's really cool about this paper is that it's very simple and quite short. So in a nutshell, they explored roughly two directions in using reinforcement learning for LLMs. The first one is what they call this DeepSeek R10 model, where they just use GRPO on the DeepSeek V3 model and found that if you just have verifiable outputs, you can actually get really good performance. But then they found that the model, although it was good at like math and code, kind of sucked at like general language tasks and was kind of unusable, or they say, suffered with readability. And so then what they did instead was they used that model to generate a large amount of, or actually, sorry, I think they collected a large amount of SFT data. And then using the SFT data, they then did the kind of conventional RLHF pipeline with the twist that, you're now using verifiable outputs. And this gives you the DeepSeek R1. And someone, I think on Twitter, posted this kind of like nice image, sort of showing the different like pipeline. So you can see here, for example, on the left-hand side, like if we just look at this, if I draw a picture here. So if we go kind of like down here, this is the kind of R10. So it's just pure RL on the DeepSeek V3 base. But then in order to kind of improve its like, human preferences and all that kind of stuff, they then took a different approach where they have some unspecified amount of like cold start chain of thought data. They do SFT, and then they basically then go through this like kind of fairly complex process of like creating an SFT model, applying rejection sampling to it, so on and so forth. And then at some point at the very end, now applying kind of RL. And that gives you the DeepSeek R1 model. So yeah, the paper is cool. It's very simple. And it feels like this is probably quite close to what, O1 or OpenAI did, because they kind of were hinting that they didn't use any search algorithms explicitly and stuff like that. So this is perhaps the first case we see of, a pure RL kind of no heuristics based method working. The other thing they did, which was quite cool, was they then, took outputs from the DeepSeek R1 model, and then they just generated a bunch of completions and then just SFT'd a bunch of these like smaller models. And they show later in the paper that basically this kind of distillation actually works better than applying like their RL recipe, which again, perhaps is reflective of what we've seen before, where people who were kind of distilling from like GPT-4 and just doing SFT on that were getting really great results without the need of any like, full-on RLHF. So that's about it. So let me just go through to the bits that I thought were kind of interesting. So the thing that I thought was like obviously very cool is that they just use this like simple prompt here, basically to take the base model, so the DeepSeek V3 base model, and then just using that prompt, they're able to basically RL from this without any SFT data. So that's pretty cool. The question I had, and maybe I don't know if you guys noticed this or not, is this the like just the base language model of V3, or is it like the instructor model?
The impression I got from just briefly reading the paper is this is the base, or at least they start with the base, and then at some point they use this version of the model to generate SFT data to do an instruct version, which they then tune with RL. But this, I got the impression this is just the base.
Let's just see, do they say here?
Without even using it supervised, wherever you just were, they mentioned it.
Yeah. So I understand that they don't use any like supervised data. I'm just trying to see where is the initialization. So the reason I ask this is like if we go to, oops, co DeepSeek v3. There's kind of two models, right? So there's v3 base. This is the base model. But then you've got DeepSeek v3, which is then the actual like kind of instruct model. And so the reason I'm asking this question is like if they started from this guy and then did all the RL stuff, that's one thing. The fact they do it without any like SFT data is one thing, but it would be less impressive than if they really did it from the base.
In this,
maybe
there's a paragraph I think above where they talk about this. I saw it earlier.
Yeah, even the title itself on the base model.
Yeah, the overview part there. Let me tell you.
You're saying like up here, it's like
in 2.1 overview. In this study, we demonstrate the reasoning capabilities can be significantly improved, blah blah blah, even without using SFT as a cold start.
Yep. Okay, that's very cool. So what I guess what's impressive, right, is that the base model is essentially able to kind of follow this this like prompt, right? It reminds me a little bit of like Anthropic's old paper on like using like LLMs as an assistant. Sorry, using like assistants as a laboratory for reasoning and stuff, where they had that like very long prompt of like 4,000 tokens to kind of induce a chat into the base model. But here it's impressive that just with that small amount of instructions, it's able to then generate these tags.
I think as well because at the first stage they focus on reasoning tasks, which are verifiable. They do RL and just like stuff where they have the ground truth and it's just 0 and 1 like rewards. That maybe makes it more simple, like more stable to train. Then you've got a reward which you could hack.
Yeah, they do mention that actually here, where they say we do not apply outcome or process reward models because we find it can result from reward hacking. Yeah, so that I thought was pretty cool. And of course, this plot is like pretty awesome, showing how you go over time to essentially reaching O1 level performance. Then there's like this this whole kind of well, actually, this is also a very interesting plot, right? It's showing that effectively, like the thoughts are just getting longer and longer over time. So it's kind of like it's like test time compute during training, which is like quite interesting.
It would be interesting to know if can you hear me? Yeah.
Yep.
It would be interesting to see if it stabilizes at some point, because I guess that in the data set you don't need like millions of reasoning steps for most of the prompts. Maybe at some point it stabilizes in the value that, like the mean reasoning steps that you need to solve all the questions in the data set.
Yep. Yeah, like what's interesting also is kind of that we also know, like in other things, like with like DPO producing long answers is not necessarily good for like non-reasoning based benchmarks. And so here it's kind of like interesting that like if I ask the model like what is 1 + 1 and it takes like 8,000 tokens to get an answer, that's obviously not super helpful, which I think they say later, where they do this like kind of more sophisticated multi-stage training to kind of blend like reasoning traces with like non-reasoning ones. Then the other thing that's very cool is this like aha moment where they sort of realize, well, they see that in one of the thoughts, the model is kind of, taking a different strategy. That's like pretty cool. I think also what's like for me very interesting is like the appearance of these like weight kind of tokens, because I've always wondered, like with O1, like how did they induce that? Was it like something that was done through like prompting or through like annotation? And at least here, it seems to just be something that emerges naturally from the data, or sorry, from the RL process, and presumably because the base model has like somewhere in its weight seen this kind of like stuff in the pre-training.
It could be the reward model as well, because you have the thinking tokens, and once it sees those in the format.
You mean this kind of stuff?
Yes. And so it's kind of rewarding it for having this thinking stuff, and then
yeah, so then let's look at this, how they train the actual R1 model, right? So they talk about, okay, they need like some sort of cold start, and so they say they need some small amount of long COT data. And then they did a whole bunch of stuff. So they basically use few shot prompting, and then gathering also outputs from the RL model and so on. And then they say that they got, some thousands of cold start data. So this is now, I think, going through the kind of like standard RL process where you kind of SFT, your base model, and then based on that, you now can do the rest of the process. So the exciting thing here, right, obviously, is that now everyone has access to DeepSeek R10. You can just do this yourself for any kind of, domain task you care about, which is pretty cool.
So they take like a few approaches. Do they mention like do they have results of what approach gives what results?
I don't think so. We'll have a look in a sec, but they seem to have just used like a bunch of different things, right? So just few shot prompting, probably the DeepSeek V3 model, and then doing this like kind of reflection verification, and then using the RL stuff. I bet there's actually a fairly large amount of work done here by human annotators to get this to be high quality. So it's not like a free lunch. Let's have a quick look actually at the evals to see if you're kind of asking the question of like, did they ablate like the SFT versus the RL?
No, I guess if you ablate the SFT, you just have this DeepSeek model without the cold start, which is not readable, right? DeepSeek R1, yeah.
Yeah, I guess what we don't know yet from just this is like, what is your starting performance, right? Like from this, once you do this like SFT thing, so you fine tune V3 on the cold start, what kind of performance are you starting with? Because this base model is already very good. So yeah, then they have this thing where it's now, okay, you've got this like SFT model, and now they're going to do basically RL on just reasoning. And then they have this like language consistency reward to prevent this like language mixing stuff, which is kind of interesting. In fact, Ed, you remember when we were doing using the Quen math models? This is very similar, right? They used to do this kind of like language mixing, and it's probably related to like the training process.
Yeah, and it was more prevalent in their RL versions. I remember the smallest model, I don't think is trained with RL. You didn't really see it. In the 7-bit higher, it was obvious.
Yeah.
When you say language mixing, is it like at some point it switches to Chinese or to,
yes.
I don't know. Yeah, okay.
Chinese.
Yeah. What's interesting is also the llama model does that if you like the 1B llama model does it if the temperature is too high. So it might be something peculiar about these kind of like models that are probably trained with a bit of RL.
And so then they kind of add some penalty in the reward model for such, well, if they detect it, right? So to
Yeah.
stop it from doing that.
So I think what they just probably count, right? Like if you look at the chain of thought, so what's in the thinking block, you probably just count like how many tokens belong to the language, and then you measure it to probably the prompt, right? So if the prompt is in English, you expect a certain fraction of English words in the thought, and then you just have a penalty on that. Actually, speaking of like the reward models, let's maybe look at that quickly before we move on. So they had this two simple rewards, right? So you've got accuracy, which is just checking if the response is correct. That's pretty easy. And then you've got these format rewards. So in addition to having an accuracy, you want a format reward, which kind of encourages the model to put its thinking process between think and think. Would that just be something simple like a regex? Like you just check like, okay, here's like when I'm doing RL, right? I generate my completions and then I check, you know, in that output, how many, like, you know, which ones basically produce the correct format. And if they don't, I get a 0. And if I do, I get a 1. Is it something as simple as that?
Could be, or inside the think, if it, you know, it might even give a higher reward if it finds words like wait, oh wait, or aha, or what if, or I don't know. But yeah.
Yeah, I think that they're really just specific. They're talking about this like formatting, right? Like I think how do you get the model to basically follow this, right? So the reasoning process and answer are enclosed within think, and then answer and answer tags. And so I guess like what I'm trying to understand is like this format, this function, right? It probably just takes the output, checks that like that there exist think and think tags, checks there's content, and if not, you just get negative reward, and if you do, then it's positive, right?
Makes sense.
And we might ensure that between answer and answer, there's actually just the answer with very little kind of, you know, there shouldn't be any kind of working in the between the answer tags, for example.
But how would you check that with a language model?
Yeah, well, I mean, it should be concise and contain like just the LaTeX with the math answer, for example. It shouldn't contain like 10,000 characters or whatever.
Yeah. Yeah, so that's pretty interesting. And then, okay, so
that's the RM for 0, right?
That's right. But I think they use the same approach when they do like the R1, right? So it's like, okay, after we fine tune on the cold start, we now do the same large scale RL process we employed for R0. So now I guess they're using the same like reward functions plus this additional language consistency thing.
There must be another RM for the more ambiguous prompts, like for that English language prompts, or like you know, the ones where the answer aren't verifiable.
Yeah, but I think though they do like I think it's like this multi-stage thing, right? So right now, I think we're here. So you've SFT'd the what's it called, on the cold start data.
Yeah.
And then they've done RL on just the pure reasoning like examples. Right? So at this stage in the training, you're just doing reasoning. And then they do this like additional stage of training where they say, okay, when the reasoning RL converges, we now collect new data for the subsequent round. And so now they collect data from other domains. And then they basically, they collect like this like kind of 600K data for reasoning from the model. And then they talk about that they collect non-reasoning data basically by, you know, generating it from DeepSeek v3 and stuff like this.
Yeah, I was referring to
Yeah.
2.3.4 actually, where they do the second round of RL. There they have another reward model, presumably.
Yeah, so just to check. So here we fine-tune the base for 2 epochs using the data set. Okay, so they've gone back to the base model at this point. So basically, once you create, basically you're back to here now. So it's like you've got that, you've got your reasoning data, and now you're doing this like kind of SFT for 2 epochs. Yeah, and so you're right. For general data, we resort to reward models, blah, blah, blah. So I guess what's interesting here, right? This is very similar to like the Tulu 3 approach, right? Where they did like, kind of PPO, or I think it was even DPO on like, human preferences. And then they've got this additional step where they did like the RL on the verifiable outputs. But yeah, like super simple pipeline conceptually. I would guess totally insane engineering, because these models are like 600 billion parameters.
Right.
Like they must have the most incredible code base ever to do fast generation, checkpointing, RL, all that stuff. Very, very impressive. And then the other thing is when they just do distillation, right? Where they basically now take the final R1 model, they then have these 800K samples, and then they just distill on top. And what's interesting is like that in the evals, if we look down here, actually here, in the evals, you can see that like just distilling on Qwen32b gives like way, way higher performance than trying to apply the RL pipeline directly. And so this, I think, is like kind of, again, confirming this thing that we talked about earlier of like, when like kind of ChatGPT came out, many people were like, oh, you have to use RL, you have to do RLHF. But we saw, many like examples in the community that if you just SFT on like high quality GPT-4 data, you get a very good model. And I think this is kind of, again, confirming that point that if the model is like small enough, distilling from a very, very capable model will give you, good enough performance. Yeah.
And the distilling was just generating data from the big model and then doing SFT on the smaller one.
Yep.
Rather than the system.
Yeah, they say up here when they do the distillation. So we directly fine-tuned models on 800K samples curated with DeepSeek R1.
Right.
On your diagram with all the steps.
Yep.
Where is it? So there it seems to imply that it's the same data they used for the SFT stage. Right, so this combined SFT data, 800K samples, like on the bottom right. So this diagram, I don't know if it's correct, it seems to imply that the same SFT data is used for the distillation as is used to train the R1 model before then the RL is applied again. So it's not generated from DeepSeek R1. This from the side.
Yeah, I think you're correct. You're talking about this block here, right? Like, is this SFT data being used in distillation and as essentially the init for like RL? And I think you're right, because if we look here, you can see here, right, it's like, okay, when the RL part converges, we use it to collect SFT data. So they do that whole thing, right? And I guess at this point, right, the model that you have, it's not really R10, right? It's kind of like R10 with a cold start. And now you use that to generate SFT data. and then they say, you know, we fine tune DeepSeek v3 for 2 epochs on that data set. And then they say we implement a secondary RL stage. So we train the model, blah, 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 and then we use this. So I think essentially what's going on here, right, is like you basically have kind of like a bootstrapping process. It's kind of like at the start, you've got your base model. So you've got like your base model here, right? Where's my picture? So you got your base model here, and you do this kind of like cold start or, you know, pure RL process that gives you kind of now something that you can use to essentially generate synthetic data. Then you generate this like, you know, kind of like reasoning data from itself or also from, you know, other sources, and you combine it, and then you again now start again doing SFT down here, and then finally RL on top. So you're right, Ed. It's the kind of outputs that are distilled don't seem to be coming from the final R1 model. They seem to be coming from these other sources.
Which is a bit surprising, by the way. You probably have
saying-
better data if you use
Yeah.
DeepSeek R1.
Yeah, I'm pretty sure. I'm pretty sure someone like Noose is gonna distill the hell out of it, which will be pretty cool.
Is it maybe the diagram which is false? Because the name is quite misleading, like DeepSeek R1 distill, blah, blah, blah.
Well, that's what they call it, right? They call it like, I mean, they call the model, I think, one distill, right? So, yeah, we have open source distill. Well, okay, they say 6 models distilled from R1, right? The other possibility, right, is that they do this process to train R1, then they reuse the same 800K prompts to generate a new set of like samples, right? That would be one alternative. But they don't seem to be saying that, because they say, okay, we directly fine-tuned using 800K samples curated with DeepSeek R1 as detailed in this section. And here they're doing all this kind of stuff. Yeah, maybe it's just a language thing. Maybe what they really did is what I said, that they train the R1 model, then they probably just reuse these prompts and then do this like rejection sampling plus, you know, other stuff here. Because otherwise, effectively, what it is it's distillation from DeepSeek v3 and the intermediate checkpoint that they got from, you know, the cold start, right? So I think the diagram matches like what's described in the paper, but it's not actually clear if it's more like this, right? That it's the R1 model doing that.
Yeah, maybe.
Yeah, I think it's awesome. Very few details, right, on like the whole training stuff, but you know, now we have GRPO in TRL. I think there's like a lot of cool things to try. One thing I wanted to ask, so there's this metric called cons at 64, which I think is what consistency at 64. My understanding of this is that they are using this as an estimator of pass at 1. So, you know, generally if you do like pass at 1, if you just generate one sample with some like sampling, you have like, you know, very large fluctuations, especially on like AME24, which only has like 30 problems. So the alternative is that you generate like, you know, many samples, and then you use an estimator to say, okay, given that number of samples, what is like the true or like, you know, potentially true pass at 1 value? Was that the same interpretation you guys had, or something different?
I didn't know actually, to be honest.
No, normally it's like magic, whatever. So,
Yeah, but Ed, remember like when we did the test on compute thing, right? We had a method for estimating the kind of like parsec k scores, right? And what we did was we generated like 2048 samples and then used that equation from the codex paper to basically estimate the kind of true parsec k. And I suspect this is similar, but it wasn't like very well described. I think they say here, yeah, we generate 64 responses per query to estimate parsec 1.
so what they estimate, they do it 64 times and take the average at the end of the day.
For parsec 1, yeah, I think that's right. Yeah, I think parsec 1 is that right.
Yep. 64 independent parsec 1s sampled, and they take the average of them.
Well, it's not that you do 64 independent parsec 1s. It's more like this. Where is it? Yeah, right. So instead, this is like from Codex, right? You generate n greater than k samples, and then you use this estimator to get the kind of true parsec k. So
Oh yeah, I remember. Yeah, yeah, okay.
yeah. So I guess what they did is they just compute 64, and then it's going to be basically 64, choose one. So yeah, probably just the average. But yeah.
So there's this section on what didn't work. That's also quite interesting.
Yep.
Including the PRM.
Yeah, they tried PRM.
Yeah, I wonder if this is like possibly like a reflection of the fact that like they're dealing with such a powerful model, right? Like, so they've got this like 500 billion parameter model, and so kind of like just from a pure computation perspective, doing like a PRM based approach is not only probably just hard engineering wise, but maybe it's just very hard to get like the high like data that is high quality enough to train like a very good PR, like a capable enough PRM.
Yeah.
Yeah, I think this is probably this is probably the biggest point is like once you have a reward model, you just have to keep retraining it, which is like a pain in the butt.
Okay, good to know.
Yeah, and I think the MCTS one is also interesting, right? Like that they didn't get to work, and they say this thing here, which is like, okay, to facilitate this, we prompt the model to generate multiple tags that correspond to specific reasoning steps necessary for the search. And so, because at the moment, right, the model is doing this like thinking stuff, and so in like conventional like MCTS, what you would do is you would like generate at like some point, maybe like a new line or double new line, and then you would generate multiple times and estimate like the kind of value of a node by doing rollouts to then work out are you correct or not. And here they seem to be saying that they generate multiple tags that correspond to specific reasoning steps. So they must have had some additional formatting to kind of indicate up until which point you roll out.
Yeah, maybe as part of the prompt, maybe you have a subsync tag or token.
Yeah. Yeah, I mean, they also talked about this thing, right? That the value model influences the quality of the generation since it guides each step of the search process. And, training this like fine-grained value model is difficult, blah, blah, blah. I think one kind of question here, right, is a little bit like if you did like the kind of prime RL method, maybe that would actually work. But again, like if you've already got something that is already working on a simpler pipeline, why add complexity?
What makes you think that it would work? Like, is it related to MCTS or I'm
No,
not
so
getting your
like,
point now?
yeah, so in the prime RL, well, not the hair conditioner. Where is the notion?
Yeah, just on the top right. Yeah.
Yeah. So here they do this like clever thing where effectively the value model is being updated during the training. Let me see.
Yeah, algorithm one, I think that's no problem.
Yeah, exactly. So here, right, they have this like implicit PRM, which is kind of getting updated on the rollouts.
Right.
And they explain a bit later on how it makes a big difference. Yeah, exactly. So you can see here, right, like if you just have some fixed PRM, you still get better, but like not as well as like if you have a kind of online PRM, right? And I think here in the DeepSeek paper, they talk about like, okay, the value model influences the generation and training a fine grained is inherently difficult, which makes it hard. So I suspect that, maybe if you combined MCTS with this like prime RL thing, which is more online, it could still work. But again, it's probably like added complexity for potentially marginal gain.
Yeah. Okay, I get it now.
But yeah, there's like, I think lots of very interesting questions, right? So first of all, like there's no kind of like replication of this, like open version of this. So I think figuring that out is like pretty exciting. And also there's like kind of like, bits and pieces of data sets available like on the hub, but there's like nothing that's like kind of coherent. And what's kind of unclear actually to me is when they did the R10 stuff. So they just say that they basically trained for like many thousands of steps, but I don't think we really know. Yeah, so you can see here, right? They trained for like 8,000 steps, but the question is like, is this like, 1,000,000 samples or is it 100 million samples? It's a bit unclear to me, unless you guys found out from the paper.
Yeah, they don't give much detail of hyperparameters, so yeah, you have no idea how big a batch is. So yeah.
And this might actually be like the kind of key missing ingredient, right? Is like, maybe it's just not enough to have like 1,000,000 samples. You maybe you really need like 20 million samples of like high quality verified data, right?
Right, so here it is the improvement that you get with the RL stage.
Yeah, exactly. So this is 8,000 steps of pure RL, and the question I have is like, how big is that RL corpus, right? Because they kind of they give us some information that okay, the SFT data is relatively small, but the question is this like here this RL stuff here, is that like humongous? Kind of interesting question. But yeah, anything else you guys want to say?
Yeah, the generation part must be quite engineered. Like they generate up to 30,000 tokens, 64 per prompt,
Yeah.
and they do it like thousands of times.
Yeah, I mean, I think this Kimi paper is like also worth looking at, right? Because this came out the same day and it's kind of on the same topic, and they actually provide details of the like architecture. Like yeah, you can see they've got this kind of like kind of RL infrastructure of like, you know, rollout workers and trainer workers and stuff. And then you can see they actually use like a full-on hybrid thing. So you've got this kind of like VLM, like sidecar, and then you've got like Megatron doing all the training. And so there's probably like a fair amount of engineering to get this kind of like stuff working together.
Yeah, with this etcd, which is like a consistency server, making sure that, you know, these processes are up and something that's used in, you know, high availability databases.
Yep.
So it is very much engineering.
It's crazy the steps they have to go to get just the weights from Megatron to VLM, right? Okay, they first have to convert it to HF format, then copy shared memory, and then update the weights. You know, it's quite a faff. Anyway.
Yeah, I mean, I think, you know, honestly, like doing this stuff, I mean, maybe they had their own reasons, but like the like Nemo aligner thing is, if you're going to use Megatron, you probably should just use this, right? Because they have like what is it? It's using like Triton TRT, I think. Where is it? Yeah, I forget where it is.
It's NVIDIA, right? So it's it's going to be Triton, isn't it?
Yeah, I forget. Yeah, exactly. So they send all their stuff with PyTriton. So I think like, yeah, once you're in Megatron land, you should probably just use that. All right. So
Nice. Have you tried the train model?
Of R1?
Yeah.
Yeah, I've been playing with it. So I've only been playing with the small model, and I played a little bit with the 32B model on Hugging Face Chat. It's quite good. Cool. So then let's figure out how to make this work in real life.
Thank you.
Right, see you guys.
See you later.
Ciao, ciao, ciao.
Yeah.